Welcome back to the Cloudcast. I'm your host, Brian Gracely. And, one of the things that, if you've listened to the show for any period of time, you know that I originally kind of cut my teeth in this industry in networking. So it's always near and dear to my heart. I love the opportunity to talk about how systems are built, how networks are built. And while I've been away from it for a little while, it's always good for me to get back talking about it, kind of digging into what's going on. And one of the things that we've probably never really covered on this show, and I'm not exactly sure why, because it's so critical, it's so important to what we do every single day, is how are the cloud networks built? How are the backbones built? How are the really important elements of the networks for the biggest environments that we work on? How are they built? How do they run? What's happening in that space? And so today, really excited to get a chance to dig into that, to cover that. And so really excited to have Vinay Tripathi, who is both a senior member of the IEEE as well as production network engineer at Google, joining us. Vinay, welcome to the show. Great to have you on.
Hey, thanks, Dan. I'm very excited to be here and share my knowledge with you and your listeners.
Yeah, no, you've got a great deep background, having worked in this space in a number of ways. Before we dive into kind of all the inner workings of how the networks are built, give folks a little bit of background on where you've been from a career perspective, where you've focused, and then maybe even some of the areas that you focus on today.
Yeah, sure. So I have been in network engineering for close to 2 decades, and I work with Juniper Networks, Amazon Web Services, and currently I'm in Google. So I spend most of the time in Juniper Networks in different roles like technical support engineer, escalation engineer, and most recent one was a resident consultant for Microsoft Azure. And then I joined Amazon Web Services, where I help them in data center edge network challenges, especially in the scaling and traffic engineering. And then I joined Google, where I work in production network, where I been lucky to be part of a great team where we solve challenges which affect all the cloud networks. Specifically, I am active in issues which impact the latency and the convergence of the cloud networks. So my most recent project, which I was working, was related to some topics which are very crucial for the cloud network, such as reliability, scalability, and optimization. So I'm excited to talk about them during the conversation. So yeah.
Yeah, no, that's great. I just the fact that you've had exposure to obviously Google's cloud, Amazon's cloud, Azure's cloud, and I always tell people, while there's a lot of folks that work on networking, if you've cut your teeth and you've learned through either Cisco or Juniper, those are sort of the best training grounds, and you check every single one of those boxes. So super excited to dig into things with you today. Let's start with something fairly big, and just in terms of a broad topic, the anatomy of these cloud backbone networks. If you had to explain this to people, maybe not to somebody who's never heard of it, but to try and give folks a sense of the scope and the scale of what you're dealing with, how big are these environments? What are the types of things that are like the most important 3 or 4 things that you're trying to make sure work properly, scale properly? Give us a sense of how big these environments are.
Yeah, sure. So before I go and talk about the backbone network itself, let me just go and talk about the overall cloud network, right?
Sure.
So that you can appreciate it better. So if you look at the cloud networks at a very high level, they are they are made out of 3 networks. One is the edge network, where the cloud providers, they connect with their external customers, internet exchanges, peering, right? Like that.
Yep.
And they also host their CDNs or mini clusters at the networks. And then you have data center networks. So the data center network is where you providers run their services. They host their services such as video, audio, depending on what is their providing, right? And then you have a backbone network. So the backbone network is the one which connects both of these. So if I have to explain it to someone who is not from networking, it will be something like edge network is something like a city, and uh, your data center is something like a warehouse, which is somewhere outside the city. And then you have expressways which connect the cities and different locations outside the city. So if you want to travel from one city to the warehouse or one city to another city, you have to always go through the expressways or like highways, right? So that is the importance of backbone. So the backbone is the one which connects all the edge networks and data centers across the globe. Now, if you think from Google, Amazon, or Microsoft, or any large cloud providers, you can imagine how complex these networks are. So they are running not within the country, they are running across the globe, and they all have to be in sync all the time, right?
Right.
So that is the complexity at the high level. At the low level, if you go further, look at the backbone network only. Backbone network is actually made out of very high capacity routers, which are mostly made by external vendors such as Cisco, Juniper, Arista, like that, right?
Right.
And they are very expensive to operate, too expensive to purchase, and expensive to design, because you need experts for those devices who know in and out about those devices which you are going to use in the backbone, and then you need the experts to manage those uh, devices, right? And then you need a army of engineers, software engineers to run the controllers who connect these devices globally, and they make sure they are in sync, right?
Yep. Yep.
So, and if you go further, break down the backbone network to understand more deeply, you'll see two layers. One is physical layer, and another is the logical layer. So the physical layer, you can think like it's like a devices itself, right? So you have routers, and then those routers has to be located in some place in your path, which are going to connect globally. So the physical layer is rack and space and device connectivity, physically connecting each of them, either through within the POP or through the WAN links globally, right? And then you move to the second layer, which is logical layer. So logical layer is a bit complex, where you run most of the routing protocols, such as BGP, OSPF, MPLS, ISS, right? And then you have data plane, so which is mostly data plane and control plane is built in within the device itself. And then you have a management plane. So the management plane is where you see a lot of opportunities and challenges. So the opportunity in a sense, imagine the scale of Google or Amazon, right? So
Right.
you have thousands of devices running across the globe. You have to make sure each of those devices are managed. You get the alert at the right time, you take the action at the right time so you don't run into outage. So that means you have to have a flawless software defined SDN controllers, right? So you need to have those type of sophistication, intent-based networks. A lot of things go into that domain, where you want to be in sync with all the devices. At the same time, you want to manage them and have the alerting system in the place.
Right. Right.
So that's like an overview of backbone. Mhm.
Yeah, no, that's super helpful. It gives both the basics, but also gives us a really good foundation to talk about some of these other things.
Mhm.
I'm curious if you can kind of give me a sense or a scope. So obviously, in your days at Juniper, you had a chance to probably work with some very large customers, large banks or large, say, video providers, and then you move to working with the cloud providers who are responsible for environments that touch thousands of customers at a time. What's the first kind of big mindset change you have to have when you go from helping somebody build an individual network, with all the redundancy and so forth, to building a system, that's responsible for, thousands of customers, and you have to understand how to make sure that one problem doesn't take down, gigantic swaths of environments. What's the mindset change that you found as you moved from kind of an individual company network to these sort of multi-tenant cloud tent networks?
Yeah, that's a great question. So when you are working for vendor like Juniper,
Mm-hmm.
you work with the customers, but you work at the very precise level. Like they might have certain requirement that they are running into power and space issues, and they are looking for some better router to replace, which
Right.
meets their requirement, right? So you are very precise in solving the problem. You don't solve their network issues. You don't solve their architecture issues because they don't want to expose those to you because it's like their own proprietary issues and challenges, which, right? So when you're working for vendor, your vision is very narrow to probably specific to the issue, specific to the platform, or specific to some software issue which might be going on, you want to solve for them, right? That's it. And then you disconnect from there. But when you go to the other end, like for example, I joined from Juniper to Google or AWS, now things change. Now you own the problem space.
Yep.
Like now the latency issue, which you were solving from the Juniper side uh, on an instance base, now you own it end to end. So what that means is the latency issue which you are owning now, you have to fix it from the beginning to the end. That means from choosing the right hardware to developing it to making sure it is part of the monitoring system, it is part of mitigation system. And at the end of the day, all the teams who are working on them, you coordinate with them, make sure everything implemented, tested, and working. So that is like a huge change in terms of ownership.
Yeah. Yeah. No, I can imagine. And just for those of us that, on the days when our favorite service goes down and we all go, okay, I looked at the public dashboard and it was more red than it was yesterday, or, you're trying to figure it out. What you're talking about is, the flip side of that, dealing with,
Yeah.
and to a certain extent, it becomes a giant puzzle, right? Making, trying to think through all the things that could cause a problem and trying to design those, either design them away or design resiliency around them and so forth. So yeah, it's a gigantic, gigantic challenge to take on. Probably very, very exciting, but complex at the same time.
Yeah, it is.
What are, as we dive into this a little more, what are some of those unique challenges that you have to think about? Whether it's, you talked about doing traffic shaping and scaling and resiliency. Like what are some of those things that are sort of top of mind to you, whether they're in the design phase or in the day-to-day phase that you're always sort of thinking about, that are sort of unique to the cloud environments?
Yeah, so when you are dealing with this network at this scale, you mostly deal with scaling challenges,
Yeah.
you deal with reliability challenges, you deal with optimization challenges. Now, if you look at these three things, let's focus on these three things, right? So if you look at scalability and reliability, you can uh, uh, keep on adding devices to get the reliability in your network. But can you really do that? No, right? Because there is a limited space in your data center. There is limited power, limited cooling. Everything is limited.
Right.
So now the focus goes to the third dimension, which is optimization. Now that is where the whole challenge is there at the for hyperscalers or people who have, or the companies who have large networks. How do you make sure that your network is scalable, reliable, at the same time it is optimized?
Yeah.
So if I have to give you example, like you try to first you start with, okay, now I'm going to scale my network. Now I know how much is my growth projection for next 5 years. Now you go start doing engineering based on that data and start looking at the device you have, what is the capability of it, how far it can go, and then you start optimizing them. Like how do I optimize it? Optimize it at the level of physical level and the logical level. So I
Mhm.
can get most of out of this device, right?
Yep.
So that is where I spend most of the time, my team, or I think I'm sure most of the cloud providers or companies who have big networks, they spend time in these three dimensions a lot.
Yeah. Yeah. And how much given the scale of those challenges, those environments, and obviously the dependency that so many companies have, how much, obviously you can only share so much, but how much of that is kind of internally grown technologies and approaches versus things that you can get commercially that anybody could go and buy today? Is it 50/50? Is it 80% homegrown? Like, how much do you have to create new things just because they don't exist in the marketplace for the size of what you're trying to do or the requirements of what you're trying to do?
Yeah, so that's an interesting question, especially for in the context of cloud providers.
Yeah,
So in the cloud, everything is changing every day. Requirements, demands, uh, availability, needs, things like that. Now, when you want to choose the platform or the software to achieve the goal, what is the fastest? Fastest is what I can develop in-house, right?
hmm.
If I can
Okay,
develop the hardware and software in-house, it's very quick. I can just gather software engineers, network engineers, put them in a room. My problem is solved. Now, that can be done for mostly in the networks where you have limited feature requirement,
sure.
limited for hardware requirements. But when you go, so it's true for certain part of networks. So like for example, you can do it probably in your data center where you have like most of the traffic in your north and sorry, east and west direction, and
Hmm.
you don't need a lot of sophisticated routing for that, right? You can move the traffic east and west with limited, maybe run BGP protocol and have some switch, which is just programming the next hops, and you are good with that. But when it goes to more sophisticated routing, such as backbone networks, if you go into the backbone networks, there you need a lot of routing features,
Hmm.
a lot of forwarding capacity, and programmability requirements, which is hard to develop in-house. Like it takes years, right? That is why you can see Juniper and Cisco who are
Right,
developing it for years,
right.
which is you cannot do it as a side business. You have to be like
It's
a
not
real
a
expert.
not a hobby.
It's not hobby.
Yeah,
So
exactly.
now, wherever you are going to interface with external entities, you can imagine like you have to have those feature sets, right? So that is like where you are going to run the devices which you are going to purchase from vendors.
Yeah.
But
Okay.
wherever you are going to have your own local traffic, you can put your own limited feature and forwarding capability devices.
Interesting. Interesting. What are as you've been doing this for a while. Like you said, change is happening literally all the time within the cloud providers. What are some of the sort of forward looking, whether they're technologies or trends that you're having to start evaluating, or you're having to start looking to put in place to solve some of these new problems, whether they're scale problems, WAN problems, where AI can help. What are some of the future looking things that are maybe on your to do list or on your roadmap that you're starting to explore?
Yeah, I think that's like pretty common for most of the places, I would say, right now. And that is, you keep on hearing about automation, right? That
Yep.
everyone wants to automate their network. And now, when you go deeper to understand why they want to automate, you will again see these three things which I try to highlight, like scaling, optimization, and reliability, right? How do you achieve that? Let's imagine you have like thousands of routers and you have army of network engineers, system engineers who are working in your organization. At that scale, you will end up with like thousands of tickets to solve those issues, and you'll need all those people attention on each of those tickets. Probably some device is going down, somewhere you are having congestion, somewhere you are having latency issues, things like that, right?
Yep. Yep.
Now, that is where I think everyone is working right now, how to take out humans from these decision making. Like when to bring down my device, what configuration to put in the device. I'm sure you would have heard about like all infamous PGP issues, which were caused by some policy changes by humans,
Yep.
right?
Yep.
So that is where like you want to make sure you are provisioning your router, you are alerting your routers, and you are mitigating those issues all by doing the automation, right?
Yep.
And that is a common theme. How do you do that? There are multiple ways of doing that. So, uh, which one of the most like software defined network, which was there like for quite some time, and then we have intent-based networking, which runs on top of that, right? So what software-defined network basically does is when you have let's go back to the conventional routing where you are running thousands of devices and each and every device is running protocols talking to each other. So every device has its own local view. There is no global view of your network. Like everyone is looking, all the devices are looking based on what data they received from other peers, and they have their own view. But that doesn't work in the very large network because you want to have a system where you can move the traffic to the different devices. If something is going down in your network, somewhere you are having congestion, you can move the traffic to the other part of your network, things like that.
Yep.
That is where the software-defined network comes into picture, where you can have your controller and you have your command system, could be CLI or your portal, where you basically uh, initiate an instruction. For example, you want to establish some tunnel, you just start the instruction from there. And now the request comes to the controller. Controller has the view of your whole network. It can decide which is the best path to take to send that traffic, which can achieve the uh, requirements you have, such as low latency or uh, high availability, okay? Things like that.
Yeah.
Now, the intent-based networking is just another layer on top of that SDN, where you go one step ahead in automating your network and you define your policies for your based on your business needs.
Okay.
Like you can have policy saying that if traffic is coming with this forwarding classification, then just establish the tunnel, and that tunnel should be highest priority with low latency path, right?
Yeah.
Now you have these policies defined in your for your network, and your network is like kind of self-driving mode. So as soon as you hit those requirements, there's policy executed, instruction is sent to the software-defined network controllers, and then those changes are pushed across your network. So you're not doing anything now. Like
Gotcha.
your resources, engineers who are working on them, they can be placed in something more interesting, challenging issues to solve in your network.
Gotcha. Gotcha. So it's really, it's a huge focus on putting the automation in place, but then also really kind of putting the business logic in place, and then allowing the system to to respond to whatever happens throughout the day. So no, it makes a ton of sense because at your scale, if you've got humans having to be in the loop, the odds that they understand all the context of what's going on and the time that's needed is probably very, very difficult and error prone.
Yep.
I'm curious, and I suspect the audience is sort of curious, and this is probably a topic that you can't easily answer in a couple of minutes. But when a problem happens, right, and most of us only see that, like I mentioned, is such and such a service is down, or so and so says, is the cloud, is some region still working? What's the as a team collectively, do you guys spend a lot of time on failure scenarios, on how do you coordinate between the DNS team, the networking team, the physical, the team that has to manage physical? Like how much time do you have to spend coordinating the sort of what if when problems happen, so that, because the clouds do an amazing job of getting all these environments back up and running. Like people complain for half an hour or 20 minutes or something, but how much time do you guys have to spend, kind of essentially doing failure scenario planning or, coordinate, like kind of pre-planning between teams so that you can mitigate those things? Or do the systems just sort of take care of themselves? They just have to work through the problems.
Yeah, I think you answered in second line, so second part. So that is where I think I would say I'm lucky. I am in Google.
Yeah,
So you can imagine Google is like a software powerhouse, right?
sure.
So it has like a very sophisticated system, and it's not only Google, but all like top three providers,
Right.
Microsoft, Amazon, all of them have similar systems. So what happens is like I don't spend a lot of time doing that operation work.
Okay.
And the reason is for a lot of smaller issues, we have uh, like, so it's you have monitoring system built, you have alerting system built, and you have mitigation. So for most of the issues, people don't even know that the problem has happened, and it gets rectified by itself. Because let me give you an example. Let's say you had an issue on one device somewhere around the world.
Right.
Now you have a monitoring system which is keeping an eye on all the devices individually at the traffic level, port level, each and every alarm on the device. What it will do is basically it will just find out that system is having an issue, then it will take action. It will alert the mitigation system. That mitigation system is going to take out the device from the network immediately. Now, no traffic will go on that device anymore. And then you have, at the same time, the bug is created to engage the vendors who are going to look at that, replace the device. So there is no engineers involved in this process. It's all happening by the tooling system itself. So you
Okay.
can imagine the level of efficiency and like, and that has like a bright side. Like, so I can spend most of my time solving the scaling and reliability optimization challenges rather than the operation work.
Yeah. No, it's fascinating. It'd be something that having done a lot of troubleshooting and manual troubleshooting in my day, I would sort of love to see how those systems sort of work and it would be fascinating to know how many of those like issues that arise that on a given day people never ever see. It's probably it's probably a large number, and the fact that it just sort of, like you said, resolves itself because the system's intelligent and can take its own action is fascinating. I want to
Yeah.
ask you one last question because I know not only are you passionate about this space and the work you're doing, but you're sort of passionate about helping to educate people about this space. What are I've heard from some people in the networking space, they're concerned that the future of sort of a network engineer, they're not sure what that will look like in a few years and so forth. What are some of the career paths that you recommend to people? What are some of the types of training that you recommend to people? If they hear this and they go, man, it would be cool to be working on the largest networks, to be working on things that have this gigantic scale. What are the areas that you sort of tell people to focus on so they can be successful in this space?
Yeah, so I think I am well placed to answer that question because, as you highlighted earlier, like Juniper background, right? So I come from Juniper where I spend most time doing conventional, typical routing, right?
Yep.
And then I moved to the cloud network. So let me answer your first question, like the concern regarding network engineering roles. So as I see, I don't think it's concern because there's enough opportunity for network engineers, even who are not interested in doing coding, because that is the one challenge people who spoke to me uh, have, like network engineers not interested in coding and now how to grow their career, right? Because
Yep.
so here is my take on that. So if you have like if you are starting your career in network engineering, my suggestion will be to develop achieve some level of certifications, either Juniper or Cisco. Aim for expert level certifications such as Juniper certified network internet experts, right? And then also develop expertise in coding. So, and why is that important? I'll just talk about that. So, you once you are once you have efficient knowledge about network engineering in general, then you can and you add the coding skill on top of that, you basically unlock the level 2 of the game. So what that means is now you have long horizon of your career, like in the sense more things to explore now. Now you are not limited to only certain part of network. Now you can even try some of the careers such as uh, production network engineering, site reliability engineering, or even software engineering, where you need expertise of network engineering and the software.
Yeah.
So I think my session will be to have like coding and network engineering, both skills to have a very successful and fulfilling career in network engineering.
Yeah, no, I think that's great, great advice. I think that was probably the moment, at least for me, that was kind of the division of staying in networking or not, because I was very good at learning the protocols, interacting with devices, CLI types of things, but didn't necessarily have that core coding background. And when I started to see what the people that had those skills were able to do, there's such a gap between them, and there was for a lot of us that didn't come from necessarily sort of coding backgrounds. It felt like a huge mountain to climb, but so many kids these days, are getting coding from computer science, or they're teaching themselves. There's all these resources on the internet to learn those things. But I would completely agree with you that if you can combine those two things, right, some understanding of how the BGPs and the protocols work, and then also have that creativity to do coding, you can do amazing things, and the sky's the limit for what you can do. So yeah, I completely concur with that, as far as that's the path to success. Well, Vinay, I'm going to kind of wrap it up there. We've covered a lot of things. We probably could go on for another hour, really kind of going in depth of these. Any last thoughts for folks that are interested in this space, like where you recommend that they go learn things, or paths that you've taken that have helped you to learn things going forward?
Yeah, so I think we are living in best informational age right now, where all the information is available on the internet, right? So my suggestion will be someone wants to explore networking, would be to start with some certification, probably uh, from the associate level, and target for the expert level certifications such as JNCI or CCI. And then in the background, just keep on developing some coding skills in Python language, which can be done either as a hobby, as a side project. You are working on routers, you just create two router topology and just start automating them, just push the configuration, get the CLI outputs, analyze the different routing protocols outputs, and make sense of the data. So that is how I learned the coding myself when I was in Juniper. So I would suggest that path will be very helpful for anyone
Yeah,
who
good
wants
stuff.
to.
Good stuff. Good stuff. Vinay Tripathi, thank you so much for the time today. Like I mentioned, we've covered a lot, it feels like, but we also have really just kind of scratched the surface on this space, and obviously it's an area that is so important to everything we do, because without the networks, without them being stable and fast and reliable, nothing else seems to work. So want to thank you for the time today. Want to thank you for helping us learn some things, and folks, hopefully that it gave you some good primers on what it takes to build and run these backbone networks and these cloud networks. So with that, I'm going to kind of wrap it up. We want to again thank Vinay for his time today. Folks, thank you all for listening. Thanks for telling a friend about the show. Thanks for helping us grow the community. And, as always, if you've got questions or things that we can help you with, show@thecloudcast.net is the easiest way to reach us. So with that, I'm going to wrap it up, and we will talk to you next week.
Okay.